This is our final project, building an HVAC system. Let's see what this was about. First, this is the system that we are going to control, and this is a list of the variables that we're going to use: the state, the manipulated, or the performance output. We have to take into account that the performance output is going to be really important in this part of the project. Then we have the process model defined by these equations. What do we have to do now? We are going to match economics and process control. First, we defined our economic objective function as a function of our performance output, specifically FR and F-fresh. This is our discretized compound system. Here is our A, B, G, and then dx and du. What are going to be the problem constraints? Here they are. When we have the problem defined, we can calculate the OSSOP. With MATLAB, we get these values. Here are the values that we had from the previous part of the project. As we can see, these values are totally the same. From the OSSOP, we get the limits of Q prime that we're going to use in the optimization. With this, we get the back-off point. But how? Here, we minimize our economic objective function with the next requirements. These are the quantitative results we got for the BOP, for S, for M, and Q. Finally, we get the EDOR plots. First, this is the C-room versus F-fresh. The boundaries are defined by our constraints, and as we can see, the ellipse is inside the box. Furthermore, we can see that we have the BOP near to the OSSOP. That means our control is quite good. Also, we have a plot of the EDOR of the T-room versus F-fresh. And finally, we have the FR versus F-fresh. Thank you very much for your attention.